I'm going to go over part one of your assignment. Okay, so part one is the bulk of the mark, 70% of the grade. You can see in front of you there during class time, we'll go through the test, which we've already done. So it was a substrate test, the exercise intensities, 10 minutes each one, and we took the VO2 and the VCO2 readings. We also in class did a wee practice of how to work out the data for the table. And 70% of your final grade based on this. So what we do is go to Appendix A of the assignment. Okay, so if you've got this, you've probably already found the assignment, which is here on Moodle. So we've got assignment on Moodle, assignment 1718. The other thing you have to look out for in Moodle is a folder here, which you put in, so references for tasks and labs. So if I click on it, you've got a series of bits of the books that I've basically saved for you. So I'll just click on one of those to show you. Okay, let's open a different page. So here we have exercise physiology, and I have copied some stuff to give you a starter on it. Okay, so I've scanned some of the stuff in. So there's a section on direct calorimetry, which we'll look at in a minute, indirect, and some bits and pieces there on how we collect the information, okay, and some stuff on direct versus indirect. There's also the equations are for RQ and RER, which you're going to look at in the assignment as well. So that gives you a bit of a starting point. And as I say, there are three, I think, of these references that actually will help you with the assignment. One is on with a Wingate, but the other three should help with different parts of the assignment just as a starting point for you. There's plenty of books in the library, there's sports discus, and there's other things that can help you, but let's make sure that you get good quality references. So from the start, I will say that the better your references, the more your references, the better your mark's going to be, because it shows good reading around the subject. So I'm going to go through each bit here, a series of questions. So we've got this is laid out the way you might have went with Damien for a research type write-up or report from last year in IT and study skills. So we've got an introduction, stroke review literature section. We have got a methodology section. We've got a results section, and we've got your discussion. And each thing can link up together, particularly the introduction and the discussion should link together at the end. So question one, the introduction. Briefly describe the energy systems and their importance and roles in different sports. What fuels are used in energy systems? So for this question, you're basically looking at a description of, well, where energy comes from, probably in the body first. So think back to ATP. I said that was the currency of muscle contraction in the body. So you need to start off in this question probably talking briefly about ATP. So what does it do? Where does it come from? How's it broken down? And what is it? Then the nature of ATP is that there's only a few seconds in the body, so we would soon run out of it. So we need to resynthesize it, and that's the job of the energy systems. Then go through each one of the energy systems. So I would probably do them in the order that you usually find in books, which is the creatine phosphate system, followed by the lactate system, or also called anaerobic glycolysis in some of the books. And then finally with the aerobic system, or sometimes called aerobic glycolysis. But obviously, especially for the aerobic side, it's not just aerobic glycolysis, which is the breaking down of sugars. It's also breaking down of fats, and in some cases proteins for energy. So go through each one of those. Devices use diagrams, okay? So diagrams will help cut down the amount of text you have to write. So stick diagrams in, but make sure you actually write about the diagrams. A lot of people just put the diagrams in and don't do any writing on them. So the diagram should be there to aid your explanation, but you still need to explain. Make sure you reference the diagrams where you've got them from. Okay, so whether you get them off the internet or whatever, make sure they're referenced. You'll find a lot of ones on the internet that you actually have in books. So if you actually find a diagram in a book you really like, you'll quite often find it now on the internet, but make sure you reference the original book. It's probably the best idea. It says about what fuels are used, so make sure you describe that. The rules in sport, an easy one with that would be, as showed in class, so they'll make a couple of diagrams, again off the web. So there's a few out there. I think it was Wilmore and Fox's exercise physiology textbook that actually has a table in it, which gives you the breakdown of the three energy systems for a whole variety of sports. I wouldn't put the whole table in, but you could summarize the table and say in your assignment, you know, this table is summarized from Fox's Physiology. I can't remember the two authors off the top of my head. So energy, where do you get energy from? The whole ATP thing, the whole 3 energy systems. The fuels, make sure you put the fuels in there that you were used. So especially in the aerobic system, don't focus just on aerobic glycolysis in the Krebs cycle into electron transport chain. Make sure you comment on where fats enter and where proteins can enter as well. Question 2, describe how you measure the energy cost of exercise or activities. Okay, I'll give you 2 types here, direct and indirect. So direct is the bomb kilometer type of thing we talked about, sort of very simple version of it you would have maybe done in school, burning the crisp, looking to see how much with a test tube of water, and you see how much heat's been transferred from the crisp into the water. You measure the temperature of the water increase, and you can work out the calories burnt. Obviously, that's pretty basic because you've got heat escaping into the atmosphere and the air. So you'd be looking at the idea more of a bomb kilometer, which is say unit, and then you don't get that escape of energy into the atmosphere. On that website, or sorry, on the reference I showed you earlier, I think we had actually a bomb kilometer there. Yep. So there's a version of a human one that just showed you in class. So somebody running a big chamber, and you've got the copper piping around, and we measure the increase in temperature in the room. So you'll find that in most of the books. You get lots of examples of the diagram that on the web. Again, a diagram easy then to explain. You also haven't got one on this, but you'll see a bomb kilometer maybe as well, and you can maybe say about that, about how to measure the food side of things. Okay, so those references are a good starting point for you that I've included. Indirect then is what we have used. So it's the ability to look at, we know how much oxygen is required to burn fats, carbohydrates, proteins. We know how much carbon dioxide is given off, and we can work out the indirect energy cost of exercise. So an explanation of that, again, a diagram is good, it'll help you explain it. On the next one, what is RER? How's it derived? So again, just as that example, if I was bringing this in, there's a section there on RER. Okay, now in this we talk about respiratory quotient. So some of the other books will have it in respiratory exchange rate rather than respiratory quotient. They're very similar. One of the questions then you get asked here in a second is to look at the let's get stuck here. If I can get, let's get rid of this off the thing. So one of the questions there at the end says the difference between RER and RQ. So this will sort of help you answer that as well. It goes through what are the concepts behind it, what values reflect. So these equations here show you what the values actually reflect, show you how, for carbohydrates for instance, this equation shows you how, the set of equations show you how RER is, or RQ in this case is 1. This one shows you how RQ for lipids ends up at 0.696, and we said before in class 0.7. So rounded up slightly, and the same then for an explanation of the mix. So anything between 0.7 and 1 then is a mixture of the two. So all the answers there for you, but please don't rely on that one reference. Try and get a few of your own as well. So then the difference there I said between RER and RQ, we measured RER, which is the exchange at the mouth. RQ is something different, so come up with the answer for that. Again, those equations are very useful. Okay, make sure you put in how RER is worked out, how it's derived. Again, we've done it in class as an exercise in class, and also there we go again. So we said our ER and RQ are fairly similar. So in this, it's CO2 produced divided by O2 consumed. With RER, it's about the CO2. It's where we measure it at the mouth. So you've got the equation for that in your notes, and say in some of the other articles that I've actually put up there on the thing for you. Number 4 then is stating your hypotheses. If people have asked about, word limits for each bit, for bits and pieces, so I've said about 2,500 words sort of would be round about the max for the assignment. Would be happy enough for that, but it breaks up differently. So this, for instance, first 3 questions here are probably going to be quite wordy. Number 4 isn't. So number 4 is going to be your hypotheses. So it started off to saying I have 2 sets of hypotheses, set 1 and then set 2, and mention what they are, and then put down what they are. Remember, they need to be simple. So the first one for each one, first set is going to be to do with energy cost and exercise intensity. You've got your experimental hypotheses and you've got your null hypotheses. So you're usually going to start out with the thing you're manipulating. So in this case, we're manipulating exercise intensity. And the thing we're trying to see if that has an effect on is energy cost. So it'll be something along the lines of a change in exercise intensity, in our case we increased it, would bring about some sort of change in energy cost. So what we expect in the experimental one is the one you expect. So an increase in an exercise intensity, what do we expect to happen? An increase in energy cost. Don't want to give you the hypotheses, that's why I'm being a bit wordy about this, but try to keep it really simple. So what did you manipulate and how? What do you expect that to affect and how? Your null then is not the opposite of that, okay, which is a mistake lots of people make. So if somebody says X will increase Y, they'll quite often think the null hypothesis should be X will decrease Y. The risk, remember, of that is what happens if there's no change. Neither of your statements covers that. Okay, so if there's no change, the increase doesn't cover it and the decrease doesn't cover it. So your null hypothesis has to be everything else that can happen other than your experimental one. So if your experimental one says increase, then your null one's probably going to say no increase or will not increase. Set 2 then, your predominant fuel and exercise intensity. Again, the thing you're manipulating is your exercise intensity. So with an increase in exercise intensity, there will be, what do you expect to happen? So a switch from fats to carbohydrates, a switch in the predominant fuel, whatever way you want to put it. Okay, but it's good actually probably includes the carbs and the fats, carbohydrates and fats in there. Your null one then is going to be again lead with your thing you're manipulating. So with an increase in exercise intensity, there will be, in this case it might be no switch. Okay, so again it's not the opposite, it's everything else that can happen. And I'll say at this point, and I'll remind you later, you're going to be testing your null hypothesis, not your proper one. Your experimental one. So when we come to look at the analysis later, it's a null one that you're going to try and actually prove or disprove initially. If you can disprove it, that means that your experimental one must be true, and then you can accept your experimental one. On your methodology. Okay, methodology is all about somebody else being able to pick up your paper and replicate your piece of research or your experiment. Okay, so they can replicate it exactly. Now, obviously, if I'm on the other side of the world, I can't have the exact same person, but I could have the same subject with the same height, weight, gender, etc. So we have enough information that the person can replicate your piece of work. So first of all, subject, relevant information, things like gender, height, weight. In this case, maybe athletic ability, how many times a week they train. Things that might have an effect on or might be relevant to your experiment. Next, equipment. Describe all the equipment which was required to carry out the test. For instance, we measured gases on an online breath-by-breath gas analyzer. What you then have to do is also put in the manufacturer and make of that gas analyzer. So it goes in the format of, as I said, we measured gases on an online breath-by-breath gas analyzer, open bracket. First thing I put in is the model. I then put semicolon the manufacturer, and semicolon again the place of manufacture. Okay, so I have to put those 3 things in close bracket. So do that with every single thing that I've actually, sorry, I said semicolon, it should be colon. I do that with every single piece of equipment that we use. Okay, so you need to get all the equipment, go down to the lab, write down all the model, make, and place of manufacture for all the equipment we use. That all goes down there. Your description of the test then is next, number 7. Describe the test from start to finish. So first thing we did, we came in the morning, we turned the equipment on an hour before to let it warm up. We calibrated the equipment. We screened the subject using a health declaration form. We put the equipment on the subject, the mask on, the heart rate monitor on, whatever else we did. We then started the protocol for the test. At the end, we cooled them down. We monitored the person. Whatever we do, we describe the whole test. Last bit there, then the test protocol is really just the intensities of time. So a table with stage 1, stage 2, stage 3, your intensity you used, so whatever percentage of maximum heart rate for each one of and the range that you used for each one of the stages, you might, and the time for each one of the stages. Also, thing people forget about is putting in the reason for ending the test. So that could be the test ended, but it could also be the subject didn't want to go on, that you thought there was something wrong and you ended the test. So what's the test protocol? Next is results 9 and 10. These are just putting in the tables and the graphs of the information that you've got. So what you're trying to do is consider your hypotheses and make sure that in there you've got the data, or the data you've shown the data that actually you need to either accept or reject your hypotheses. So your tables in there, your graphs then of the important stuff, such as, well, if we're looking at calorie cost and you want that in against intensity, you want the type of fuel being used in against intensity. The assignment's using RER, so you probably want that in there. RER is derived from VO2 and VCO2, so you might want those in there. So think of the key things that you want and get them in your table and your graph. You don't discuss your results in here, you reduce them. So you can say the table below shows X, Y, and Z. Put the table in, you make sure all tables throughout the assignment and all graphs and all diagrams are clearly identified. So table number 3, whatever it is, or title, graph 2, title, diagram 1, title, whatever it may be. Okay, and then you can refer to those easily in the text. Down to the discussion, then we're back to doing a bit more writing again in the discussion. So number 11, describe the subject's results and analyze them. Make decisions accepting, rejecting your hypotheses from number 4. So go in, brief description of the results, and then by analysis what we mean is try and think in statistics terms. Now we're not making you use any statistical analysis in terms of formula or anything, but think about the sort of phraseology used for describing data. So if I have said that with X there's going to be an increase in Y, and I've my null hypothesis with an increase in X, there's going to be no increase in Y, then I need to look at my data. So for instance, if I've got a graph of X against Y, and as X goes up, Y goes up, think about what that is. It's a positive correlation. So I can use that type of phrase to make a decision to accept or reject my hypothesis. So if my null hypothesis with an increase in X, there will not be an increase in Y, then I can clearly state from my graph, you can see that as X increases, Y also increases. This is a positive correlation. Therefore, we can reject our null hypothesis and we can accept our experimental hypothesis, okay, which is with an increase in X, there will be an increase in Y. Okay, with an increase in exercise intensity, there will be an increase in energy cost or whatever it may be. So we go through that, each one of hypotheses, null one first, accept or reject, and then either accept or reject your experimental one based on what you've done with your null hypothesis. Okay, so that's your description. Describe what the data, what's happening in data, rise and fall, and one against the other, correlation types, reject, accept your hypotheses. Number 12, then you're going to have to start thinking about why the results have turned out the way they have. So I've said there, i.e., why does the energy source and cost differ over the 3 exercise intensities? Well, very easily for the first bit, as you increase your exercise intensity, you need the body to do more work. The legs have to turn over faster. That means you need more stronger, more forceful muscle contraction, and probably more of them. What do you need to do that? You need ATP. ATP runs out, you need to resynthesize it. The energy systems start being used. The more stress you put in the energy systems, what happens? Okay, so the aerobic energy system initially can deal with that, but as it gets harder and harder, maybe the anaerobic system has to kick in a bit to help the aerobic system out. And even within the aerobic system, carbohydrates are broken down faster than fats. So as we approach the top end of the aerobic system, fats become harder to use and carbohydrates get relied on more. Okay, so I'm putting that very simply. You need to back that up with the literature. And it's the same then with the swap. That's sort of describing why there's a swap from the maybe potentially from the fats to the carbohydrates. And it's also saying why you need more energy because you need more muscle contraction. So, but they need to relate that to what's in the books, in the literature, in the journals, whatever literature you can find. 13 then, discuss how results reflect or conflict with what is written in the literature. To answer this, you must, and I put it in bold letters because people do it every year, forget to do it, refer to the relevant literature. So think about how your results reflect to your discussion. What you know about increasing energy and the requirement for increased energy, the harder you work. The reflection of using more carbohydrates and fats, the harder you work. You'll also find lots of diagrams that will look like probably the graph that you end up with. So if I go to most of the books, again, I will find something that has the type of graph that you'll end up with, where you've got exercise intensity along the bottom, and you've got percentage of calorie burnt along the y-axis, and you'll have the percentage of fats with a negative correlation, a percentage of carbohydrates with a positive correlation. You'll find diagrams like that in lots of books. All you have to do is be saying, Joe Bloggs, whoever it is, in his book, or state that with an increase in intensity, there is a switch in the predominant fuels. This agrees with my experiment, or with my results, sorry, I should say. So you'll find lots of that in there. So try and find a few really good pieces of supporting evidence in the literature to back up what you've said. And that links on to the previous question 12 as well, or with the previous question 12. 14's really just you coming up with this. What practical use can knowing the type of fuel, energy, cost, exercise, activities have? So, we know how much then energy possibly we need in a day to make sure we refuel properly. We know that if we do a certain type of exercise, we need a certain type and amount of fuel to recover from that. We know that to run a marathon, we maybe run out of carbohydrate. So along with things like muscle biopsy that tells us how much energy we have in the body stored in terms of carbohydrates and fats, that tells us if we're going to run out of it. We know how much we have to replace after exercise to make sure we top up those reserves. We can, if we know the energy contained in our foods that we eat, we keep a food diary, our food journal. It means that we can balance that with the amount that we're actually burning off. So we can choose then to gain weight, lose weight, have a similar weight. This is pretty much common sense, most of this for this question. Number 15, limitations. Again, it's not from the literature. This is what limitations you have. Think about the number of subjects you used. Things about that subject. Would the results been different if we had used females, if you used a male, or vice versa? Would it be different if we used an endurance athlete rather than a multi-sprint sport athlete? What things have we used that we could do, we've done more? The mode of exercise, the amount of time we spent, the type of athlete, the gender, the etc., etc. So that again is limitations that you can find there. How you might improve those things. And the easiest thing for talking about the subjects is more of them, for instance. So for each limitation that you think of, how could you have improved it? Lastly, summarize your paper in 1 or 2 paragraphs. At the start of most research journals, most research articles, you'll find a thing called an abstract. And really what I'm doing here is the other way around. I'm asking you the abstract at the end, just because usually we do summaries at the end of most work, is to get you the idea of this summary. Colour paragraph summarising everything you've done. So what did you discuss? Sorry, what did you find in your introduction? We have looked at energy systems. We have looked at different methods for measuring the cost of energy, cost of exercise. We have looked at whatever else we looked at. We tried to find out X, Y, and Z. We used one subject, male, female, age, whatever it may have been. Then looked at the methodology. So we use a breath by breath analyzer to look at VO2 minus VO2, VCO2. We worked out respiratory exchange rate, etc. At the end, we rejected our null hypothesis. We accepted the following hypotheses. We thought this occurred because X, Y, and Z, main things. It's a real summary here, okay, in sentences. You're really summarizing what you found, okay, in a couple of paragraphs. in the future we would do this differently by adding more subjects. Okay, so lastly, your references. So be consistent in the system we've used. I showed you the other day how to use the word to actually reference inside Word itself, which might make things a wee bit easier for you. Make sure citations, your references are consistent approach throughout. Make sure they're all in there. Don't secondary reference. Make sure it's from primary sources. Be as varied as you can, but really do look for that peer-reviewed literature. So things like journals, quality textbooks, quality websites, sports disc stuff off sports discs. So your referencing isn't just about getting some point marks for the reference bit of it. Your reference about making sure that the quality information you use will come across into the rest of the work. Okay. Any questions? Then drop me a message or ask me in class. Okay. Hopefully this has been useful for you, and I'll pick this up again in class.